Okay, lesson 16, ratios, rates, unit rate. We're starting a new chapter today, so therefore we're going to go through some basics that we might have missed out on last year. So ratio, if I'm talking about ratios, it's really simple. We're just talking about a number being compared to another number. So a ratio is a method of comparing two like quantities. Now those like quantities are just talking about the same things. So for example, if we're talking about this example down here, we're talking about a square being compared to a square. So we're comparing measuring units to measuring units. Always reduce. So if I have something that finishes like this, 7 to 70, it will not tell you, but definitely divide by 7 and divide by 7 for a final ratio. You'll notice that ratios and rates are a lot like just fractions. A number being compared to another number. There's different ways you can actually look at these fractions. You can write them like this, 1 to 10 ratio. You can write them with a fraction bar, like that, and sometimes it's sideways. And also using the words a 1 to 10 ratio. So you could either write it either way. I pick on most often the one that looks like a fraction bar. So if I'm comparing, so if in this we're talking about comparing the perimeter of the small square compared to the big square, it's exactly what it says in the same order. So the small one. So for example, if it's a square and maybe this is a 6 and maybe this one here is a 9, if I'm going to compare the two, so the perimeter of this one here would be 6 times 4, would give you a 24, and this one here would be 9 times 4, would give you 36. So if I'm comparing those two, the word small is first. So because it says this first, you must put that first. It's as easy as that. So you would put 24 ... if you prefer, and you're comparing it to the big perimeter here is 36. It's as easy as that. You just put your numbers in the right order. If you can reduce, always do so. So I can clearly see that I can definitely divide by 2. Maybe I can divide by something bigger. I can see I can divide both by 6. So here, divide by 6 is a 4. Divide by 6 is 6. And then I realize again that I can divide each one again by a 2. So my biggest divisor there would be a 12. So I do get a 2 to 3 ratio as a final answer. So this one's just comparing things that are similar. So you were comparing the square to the square for ratios. It could be comparing boys to girls. So we're talking about the same type of thing. If it's talking about orange fish to blue fish, we're still comparing fish to fish for ratios. When it comes to rates, this is when it starts talking about unlike quantities. So things that are very different. Now this is what happens more often in the real world, is we're not really comparing, depending on what we're doing and what we're comparing, what's the stats looking at, the data. But we are more often seeing this in the real world, is comparing two things. So the big one obviously is, cost per kilogram. So obviously you guys are not going grocery shopping, but this one's a big one just because we're talking about, okay, so many kilograms cost you so many dollars. If you're talking about driving a car, a big one would be cost per liter of gas. And other ones, maybe in the medical field, you could have your heartbeats per minute to compare those. So when words such as in, per, by, for, each are used, they use words rate rather than ratio. It is expressed in an oblique, that just means my sideways bar, a horizontal bar, or in words. Trying to think of some other ideas here of ratios. sorry, from rates, comparing rates and ratios. Your rates also could be, if you're talking about a sprinter, right? So how many meters can they run per second? So this would represent time. This represents distance, right? So meters. So this would definitely be comparing two things that are not the same, distance and time. So really both of them, ratios and rates, is just a number compared to another number. On the second page of your notes, unit rate. Last year, you guys really focused on unit price, and that was easy because in that case, you were always dividing money over whatever your item was. I do have a little trick because it's not always going to be money. So last year when you did this, to find out which one is the better deal, you would want to know how much per, how much money per one item. So one item cost would give you a better idea of what would the better deal be. So for example, here I would say $1.25 divided by 5. I could say $2.65 divided by 12. So my $1.25 divided by 5, that is a nice easy calculation, right? So it's going to give me 25 cents per pencil. My $2.65, I'm going to have to use my calculator for that one. My $2.65 divided by 12 items will give me a 22 cents per pencil. So then you can clearly see that my better price is definitely the 22 cents per pencil. Now my trick is that if you don't have money involved in the question, so for example, the one I always use comparing monkeys and bananas, okay? So if I have 12 monkeys and I have 72 bananas, and I ask you for a unit rate, logically what would make sense would mean how many bananas per one monkey. So my trick is the one thing you want to find bottom of fraction and divide. So for example, it's clear here that you're not going to say, okay, how many parts of a monkey are going to be eating only one banana, but obviously how many bananas per one monkey. So in this case, I would put my bananas on top of the fraction, and I would put my monkeys on the bottom. So whatever is on the bottom always represents the one thing. So when you divide this, and again, I have no idea, 176 divided by 12, so 176 divided by 12, each monkey will get 14.67 bananas per one monkey. So that's my biggest trick. Always put that one thing that you want to find on the bottom. Next part. So there's 4 parts to this lesson, right? What is a ratio? What's a rate? How do you do unit rate and how do you find it? And then comparing ratios and rates. So this one here, we have lots of different methods, but if we're talking about a ratio or rates, we're just talking about fractions, right? These are just fractions. They're a number compared to a number. So for example, if I'm comparing 2 different bits of data, so let's say I have one that's 7/8, and I have different data that is giving me, 9/10. You can definitely, if you want to know which one is greater than, less than, or if they're equal to, the easiest way to do this, common denominator would be 1. I know how much you guys love that, is times 10 times 10. That would be a 70/80. And this one, if I'm saying times 8 on top, that would give me a 72. So then you can clearly compare and say 70 over 80 is less than 72 over 80. Or you can keep it really simple. Quotient just means divide them. Decimal. Now if I'm using the same numbers again, I'm going to obviously have to use my calculator. But for this one, no, right? 9 over 10 is a decimal 9. My 7 over 8, I definitely have to use my calculator. 7 divided by 8, what does that give me? Round 2 places there, 0.88. So this one I get 0.88. You do have to be careful sometimes because sometimes they're so close together you have to look at 2 or 3 decimal spaces. So again, you can clearly see that decimal 88 is less than decimal 9. So if you have to compare two fractions, just change them to a decimal or common denominator. Obviously, most of us will go the easy way, right? And obviously, dividing one here is an easier and more popular method to use.